My name is Grant Poole. I'm the water quality specialist for the Pokagon Potawatomi. Today we're covering the presentation on the longitudinal survey of the Dowagiac River. Later in the presentation, you'll see Doug McLaughlin from WaterWays SMC. He'll be covering the monitoring and study design later in the presentation. To give you an introduction, the Pokagon Band of Potawatomi is in southwest Michigan, northwest Indiana. We have a 10-county survey areas, and the map provided gives you a sense of the watersheds we're part of. The Dowagiac itself is a subwatershed of the St. Joe River, which flows into Lake Michigan. In 2022, my department, Kowabdanawa, which means we look over this land, received the BIA funding for a longitudinal survey of the Dowagiac River. Our hopes were to survey 39 miles of the Dowagiac River to provide some interesting modern tools that our watershed partners and our tribe itself could use to better protect and preserve the Dowagiac River. We want these tools to be provided to the public via online services to make them useful and educate the public around us. The Dowagiac River is unique because it is one of the more southern cold water fisheries found in the state of Michigan. This is due to the amount of glacial tills and groundwater found within the area. Managed as a trout stream, it has natural reproduction in many cool water species. Several of these now are migratory fish species from Lake Michigan. On the main stem itself, back in the 1920s and 30s, 99% of the river and streams were dredged and channelized for agricultural purposes. It's not until recently that we have started to restore some of those natural habitats. This includes the removal of Pucker Street Dam and 2 remeander projects that have increased the river length by over a mile.
My name is Doug McLaughlin. I'm the founder and director of WaterWays Science Education and Management, SEM. I'm going to talk about the data types that were collected and the methods used to carry out the survey, and the river features and conditions that we mapped along the way. I'll provide a little information about the data processing flow from being on the water in a kayak to creating a story map to help users access at their own pace all the information and data that we collected. And I'll share a list of the key deliverables from the project. In a nutshell, this approach to conducting a river survey is all about paddling a river with a specific plan for gathering a wide variety of information useful in managing waterways. The equipment used is relatively inexpensive and easy to use, which allows for lots of information to be gathered in a single trip. The basic elements are shown as bullet points on this slide. 2 similarly equipped kayaks paddled by trained surveyors were on the water together for each segment of the river that was surveyed. Equipment on each kayak included 2 GPS-enabled GoPro Max cameras, which provide 360-degree recording and viewing capability. One of these collected continuous video and the other took a time-lapse image every 10 seconds. Each kayak had a continuous audio recorder that was used to capture verbal observations of the surveyor of a specified list of things to look for. And I'll talk more about that in a minute. One of the kayaks had a 7-parameter water quality multi-probe provided by the Pokagon Band that recorded surface water temperature, dissolved oxygen, conductivity, turbidity, pH, nitrate, and chlorophyll A. Every river mile, we dismounted from the kayaks and conducted river habitat assessments using the state of Michigan's Procedure 51 method. And each kayak was equipped with sonar to collect water depth, aquatic vegetation density, and river bottom hardness data using a BioBase subscription for data processing. Our objective in the survey was to be able to identify, describe, and map a number of water quality features and conditions that are relevant for management. You can see them listed on this slide, and in addition to the habitat assessment, the list includes shoreline erosion, water quality, including observations, visual observations of changes in water clarity, landmarks and infrastructure like bridges and high voltage power lines crossing the river, a variety of water inputs to the Dowagiac River, a list of easily identified terrestrial and aquatic invasive plants, excessive floating and submerged algae, trash and junk, with junk referring to larger items such as bicycles, trampolines, shopping carts, tires, and the like, and several others that you see here on this slide. Because of the different equipment being used and the different types of data that were collected during the survey, I created this flow chart to help illustrate how each type of data were processed and turned into different project deliverables, which I'll talk a little bit more about in the next slide. One of the key objectives of the survey was to create a virtual tour that could be publicly available as part of the EarthViews virtual tour atlas. If you're not yet familiar with it, think Google Street View for rivers, enhanced with the ability to show all kinds of relevant river data. In a minute, I'll demonstrate how the EarthViews platform works by briefly exploring some of the Dowagiac River survey data. Another key highlight in this flowchart relates to the use of the audio recorder to record verbal observations. You can see that box in the flowchart in the upper left. The audio recorder captured all of the verbal observations in a WAV file, which was then uploaded to an online transcription service for conversion to text. The initial draft was followed by additional editing. The time elapsed of each observation was the elapsed time of each observation was combined with the GPS data from the continuous video camera to create a spreadsheet of each verbal observation in text version, along with its latitude and longitude coordinates. I'll talk more about the importance of this to the overall survey project in a few minutes. Lastly, the flow chart shows that we ultimately found the Esri story map format to be a great way to combine all our media and data types into one place that also gave users the ability to explore the results at many different levels, from quickly perusing short video clips of the river to doing a deeper dive into the project data with links to publicly available data dashboards. A quick summary of key deliverables is given on this slide, including the online interactive virtual tour with accompanying satellite map, a number of clips of continuous video, again with 360-degree viewing capability, a master spreadsheet of geolocated verbal observations with each entry, including a link to the virtual tour location for that observation, interactive data dashboards for all of the sensor water quality data, the habitat results, and the continuous sonar data. And because the survey is being conducted to help prioritize river improvements, we put together a short list of links to funding options for different types of river improvement projects. Finally, I mentioned the project story map, which is not quite publicly available yet.
Okay, thank you, Doug. As part of this project, we created several tools. One of them is a story map. Unfortunately, our tribe is under current negotiation with Esri, and as part of that process, they have frozen our accounts, so that story map is not public yet, but we will show you some of the components that are located on the story map. One of those first components is these tabloid figures. I will now jump into those figures. One of the first components we want to look at was habitat on the Dowagiac River. The state of Michigan has this Procedure 51 habitat, quick habitat form that they use. From these forms, you can go out and select the point on the river and look at the different substrate types, the meandering of the river, the vegetation, the riparian zone, and different flow characteristics to see how good is the habitat out there and give it a score. In this case, we did a habitat survey every mile. Overall, you can see the scores range between 33 and 166. If I were to move this bar over to about 105, this just puts us in the category where all the good to excellent points are. You can see only 3 occur with good to excellent habitat. The majority of the Dowagiac River ends up being marginal. We can then reverse this and also look at the poor. So if I were to go down into the 50s and 60s, you can see a lot of the marginal to poor end up being in the upper reaches of the Dowagiac River. If I were to zoom into that area, you can see this tends to be our more agriculture ditched area. What was once a nice wetland is no longer there. If we were to do restoration or other activities to restore the area, you can see these different components. We can see that maybe you want to look at riffle bend the frequency, increase that, or embeddedness. We can see embeddedness is getting some low scores. So this gives us a starting point to work with partners to say, hey, we can maybe do some habitat restoration in these areas to improve the Dowagiac River and hopefully bring it up into more good to excellent condition versus marginal. One of the next figures we have is from data that Doug used from a sonar or fish finder. In this case, one of our first things we can look at is biovolume. In this case, we didn't really see too much. If I were to move this slider back and forth, you would see very few changes to the actual data set. So biovolume did really not give us much information. If we switch to hardness, you start seeing some interesting things when you get to the upper, higher scale. This could be where the logs or gravel areas are in the Dowagiac River, so that may be interesting to people looking for areas to fish or harder substrate. You can also do that with looking for speed. So if you're looking for riffle run areas or currents around log jams, you can move that up and start seeing where some of these higher current areas may be. So this gives you just little starting points that people who may be interested in these things can look at. Dowagiac River has several guides, so that could be helpful with our fishing guides. Same with water depth. If they were looking for some deeper holes, sometimes that's important in the wintertime to find those deeper holes. They could look for where the deeper areas are within the river and maybe target that for different fish species. So there's a look at the sonar results from the Dowagiac River. The next figure covers the aspects of the multi-probe we had Doug use as he was going down the river. This gives us all the parameters of chlorophyll A, conductivity, dissolved oxygen, nitrates, pH, temperature, and turbidity. The probe itself was recording the points about every second, so we have quite a few points. In this case, we have 1,486 recorded. Let's start with conductivity as an interesting one. So here's a representation of conductivity. Ranges between 0.30 and 0.80, which is not too bad. It seems fairly consistent. If we were to look at the lower range, though, we'd see kind of a sporadic points pop up here. Not too sure why this is occurring, but some reason we're getting some small points. That may be because the probe getting on the water or something like that. But if we look at the opposite, we look at the upper reaches, you can start to see a trend here where the higher conductivity is more in the upper reaches again, where that agricultural area is at, and it just kind of moves slowly down until we get down to the mouth of the river. So that gives a sense of a little bit about things going on conductivity-wise. Dissolved oxygen. Again, dissolved oxygen rating is between 4.55 and 16.9. Overall, we're like, oh, that's kind of a dramatic range. If we go to lower section, we can see again is occurring up in this agriculture area, so we're looking at maybe some slightly dead zones, but it's likely due to some siltation area or high granitic areas. Same thing though is true for the opposite. If you were to go and just look at the upper oxygen levels, we see those are in the same areas, and that makes you scratch your head and say, why is that occurring? Well, this is open water area. Lots of aquatic vegetation and algae in the water. If we were to switch over to chlorophyll, and you'll see the same kind of things. For chlorophyll, if we were just look at the, just move this up a little bit, you can see all the chlorophyll regions tend to be up here in the upper regions. This is where a lot of the algae and aquatic macrophytes are occurring. So when we really wanted to do this studies, the Dowagiac River is a cold water stream with a trout fishery, so we're kind of interested in temperature. If we were to click on temperature, one of the first things we want to know is Or we're getting warm water inputs. We see 82 degrees. Now that's kind of concerning, but our break point's right about 71 degrees. And when we look at just that area, you can see only a few points are up in those higher level temperature concerns. This kind of tells me this is the open area, kind of agriculture area again. And then we're down here by the mouth of the river, which is St. Joe River itself is a warm water stream, so that makes some sense there. Not too sure why we're getting this one point here, and maybe the probe came out of the water. We want to look for where the springs and cold water inputs are coming in. We kind of move the scale down. I can just kind of see some of these areas where there's likely quite a few springs or cold water sources coming in that keep the Dowagiac River a nice cool trout stream. So those are probably areas we need to protect or understand better. It's kind of odd that we're seeing this up here in the upper reaches, but it tells us that it's cold water stream all the way up and down. Currently, I think this section of the river is considered more warm water than cold water, but maybe that could change in the future. Another interesting aspect when I was going over this data was nitrates. I click on nitrates. Again, water quality standards for nitrates would go with the drinking water standard of 10 milligrams per liter. We can see these high numbers up at the 9. So we start in the 6 to 9. You see when they get the filter out, we tend to get this component right here in the Dowagiac River. When you zoom in, you can see this is where the municipal airport's at, but this is also the Dowagiac River water treatment plant. So we're seeing probably some effects of that plant on the Dowagiac Creek, which flows into the Dowagiac River. Standards are below drinking water standards, so not too much we can do there other than document that we're seeing some high nitrates coming in through the Dowagiac River area and the town of Dowagiac. And overall, the Dowagiac River itself is probably elevated, but not up to concern that we are thinking of. For some of the other components, pH, you can see on pH 7.88 to 8.99, really not much of a difference there occurring. If we were to look at the upper reaches, nothing really pops out, just a couple little points there. And the same thing if we go down to the lower reaches. Nothing that we can really pinpoint to say, oh, what's going on here? Again, maybe some driven by this agriculture area up in the north. But nothing too defined, and the range is fairly small. Same can be said for turbidity. Some big readings of 90 and above. 50 is usually the area of concern we start looking at again. Up in this area, and I'm guessing these are mainly because it's a very silty, low elevation water system. But the probe was probably hitting the bottom, or sediments were getting disturbed. But it's not an overall trend that we're seeing, so not too much concern about turbidity, other than we know that sometimes it spikes up. So those are some interesting kind of starting points the public can use to figure out some things going on in the Dowagiac River in terms of chemical and physical attributes. Now I'll turn over to Doug.
I want to very quickly show you the virtual tour for the Dowagiac River on the EarthViews platform. You can see on the left-hand side of the screen the 360-degree photos, time-lapse photos with direction arrows that allow you to advance or back up. And again, it's 360-degree video, so it makes it easy to get a better feel for the river environment. And then on the right-hand side of the screen is a satellite image. You can toggle between the satellite view and a typical road map view. The blue line here shows the path of the kayak. The red triangle shows the position of the kayak on that route. and the direction that it's facing. Near the top right is a menu, a drop-down menu of different layers of data that have been added to the virtual tour. So, for example, here you can see a number of water quality parameters from the water quality multi-probe. There are maps of individual observations that were taken, like landmarks, navigation obstructions, severe erosion, trash and junk. Again, many different types of observations were made. Also, near the bottom of the list are the sonar data, which includes speed estimates, as well as water depth, bottom hardness, and aquatic vegetation. The Procedure 51 locations and site average scores are given, and then also links to video segments that were created to highlight different components of the survey tour and allow for a more the continuous video immersive experience. So we invite you to explore all of that. I also mentioned that one of the key deliverables is a master Excel spreadsheet that contains all of the verbal observations and information about those observations. Here is a sample of that master spreadsheet for the Dowagiac River. You can see there's a lot of information provided here, including categories of the different types of observations that were made, the actual observation that was captured by the audio recorder and subsequently transcribed into text, the location of each observation, the lat-long coordinates for each observation, and then also a link to the EarthViews tour associated with each of the observations. So clicking on the link takes you directly to that location. For the purpose of this presentation, I'll click on one of the observations, which is about a bridge. It says the bridge, we're immediately underneath the bridge. So I can click the link and that opens up the virtual tour to that specific location. You can click the arrows to go forward, and again, pan around to get a better contextual picture view, that is, or sense, that is, of the river. So then we can back up. We can use this arrow to back up if we want, go forward. And you can see again where the location is on the right side of the screen in the satellite view. And we happen to, this is the bridge at New Swamp Road.
As we wrap up this presentation, I can give you a couple examples of partners that are already using their data. Even though the story map is not out to the public quite yet, we were able to relay some of the information in terms of water withdrawal locations, mainly agriculture and other people removing the water from the river, to EGLE, which is Michigan's Environmental Great Lakes Department. The state of Michigan's DNR office has also asked us for information, and we passed that on to them so they can figure out their fishery surveys this year on the Dowagiac River. And then we've presented to several of our watershed partners, Friends of the St. Joe River, the larger group that covers the whole St. Joe River, really started this kind of project 3 or 4 years ago, and then we just expanded upon it. And so they're finding the added components of data that we've added to it is interesting and intriguing to them, especially in the EarthViews where you can pull up junk and debris that has triggered a few river cleanup possibilities. Meanders group is the one for watershed group directly on the Dowagiac River. Lots of fishing guides are associated with that group, and so they're looking at the data, trying to figure out the best paths and areas that could be better access for fishing. So yeah, I think we were off to a good start. Once the entire story map becomes public, I imagine a lot more public input will be heard and more activities will occur. From my department to everyone, we'd like to say miigwech, thank you for sending in this presentation, and feel free to reach out to us if you have any more questions. Thank you.